All right, everybody, welcome to the video here for lesson number 5. The title of the lesson is Putting It All Together. It's basically what are the operations that we have to be able to do for polynomial functions. So, the first question here is a subtraction problem. So to do a subtraction problem, I always do a distributing. I think it's just easier that way. If you could do it with mental math, great for you. But after I distribute, I should be able to clearly see my like terms. Remember, when I'm writing my polynomial answer, I want to put it in standard form, which means put it with the largest exponent first. So negative x cubed, the negative x cubed is negative 2x cubed. We have 2x squared and 3x squared, which makes 5x squared. I have negative 9x and negative 7x, which makes negative 16x. 1 and negative 1, which makes nothing. So this would be a cubic polynomial. For number 2, before I can do the subtraction, I do have to do some multiplying. So let's do this first one, and then let's see if we could use it as a model to do the next one. So if you notice, these two middle terms are going to wind up getting added together to make 6. So it's going to be 3 plus 3. And this last term is 9. So essentially this first expression, x plus 3 squared, becomes x squared plus 6x plus 9. Well, how did I get that? I added 3 to itself to make the 6. I multiplied 3 to itself to make the 9. So let's use this process to factor x plus 4 squared mentally. So I know it's going to be x squared. 4 plus 4 is 8. And 4 times 4 is 16. Seeing the same structure helps us identify how to factor that pretty quickly. Distribute the negative 1/2 or do subtraction. If I do subtraction, the x squareds cancel. I'm going to get negative 2x, and I'm going to get negative 7. Number 3, a couple of you in class started this homework and got to this point, and a couple of you asked me, what should I do first? Should I try and create a common denominator? And you could, and that would totally not be a wrong thing to do. It would just make a messy problem, and I don't think you'd want to do it that way. What I would do is I would just quickly do some synthetic division. And see that the first division problem comes out to be x minus 2. The second division problem comes out to be x squared plus x plus 1. Add all up and you get x squared plus 2x minus 1 as your final answer. So we don't have to really do a ton of extra work here. We just have to do some synthetic division. Number 4 is a really good question because if you remember some factoring from 8th grade or 9th grade, whenever you took algebra, you'll notice that this is something that factors from this expression, and this set of polynomials is what factors from this expression. Why? It's difference of 2 squares. That's something we should know. Now, if you had to, you could go through and do the whole box multiplication and do the whole thing out if you want to. You'll notice the middle terms cancel. So then if you do your distributing or subtraction, the x squareds are going to cancel, and you're going to get negative 9 plus 16, which is just the number 7. Number 5 says determine the first and last term of the expression. So the first term is going to be the largest term in each parenthesis multiplied together. So that's going to be 3x times negative x times 4x. So that's going to be negative 12x cubed, which tells us this is a cubic polynomial. The last term is going to be the smallest term of each parenthesis, so that's going to be negative 1 times 2 times 3, which is winding up being negative 6. and that also is the y-intercept. Number 6, unfortunately, is a little bit of geometry. So we first have to find the perimeter. We then have to find the area. Let's find the perimeter first because that would be the easiest. So notice there are two sides that I don't know. I don't know this side, and I don't know this side. So I have to find them. So I know the whole height is 15x plus 10, and this partial height is 6x plus 8. So if I subtract those, I get 9x plus 2. Notice the entire width is 10x plus 30, and this partial width is 2x plus 15, so that would make this 8x plus 15. Add up all of your like terms, and you can find your perimeter. So I have 10x, 25x, 27x, 36x, 44x, 50x. The numbers 30, 40, 55, 57, 67 plus 5, so 72, 80. There's your perimeter. To find the area, you have to block it off so that we have two different shapes. We'll call this shape A, and the rectangle would be shape B. They're actually both rectangles. So if I want to find the area of A, I would do 2x plus 15 times 9x plus 2. If you multiply all that out, you're going to wind up getting 18x squared. You're going to get 4x plus 45x, so 49x plus 10. And I know you all know how to multiply, so I'm just doing that part kind of quickly. The area of B, I have 10x plus 30 and 6x plus 8. So the area of shape B is going to be 60x squared. I'm going to wind up getting 80x and 180x, so that's 240x. And 30 times 8, which is just 200. And actually, I just noticed I had a mistake here. That's actually 260. 80 and 180 is 260. So then if we combine our like terms between the area of one shape and the other, and have the total area is going to become 78x squared, 309x plus 250. Number 7, compute using long division and synthetic division. So I'll do long division first just because it's more challenging. Get it out of the way. So I have x to the 4th minus x to the 3rd minus 6x squared minus 9x plus 27. First term is going to have to be x to the 3rd to make the x to the 4th. These are going to cancel. That's going to become a plus. So we're going to get 2x to the 3rd minus 6x squared plus 2x squared. So that's going to become 2x to the 3rd minus 6x squared. Both of these are going to cancel. So then we're going to bring down both the negative 9x and the 27. So then this will become minus 9. So it'll be minus 9x plus 27. Same terms. They both cancel. No remainder. So there is your answer. Now, if I was to do this with synthetic division, I'd put 3 in the jail or the box. I'd have 1, -1, -6, -9, and positive 27. The 1 comes down. 1 times 3 is 3. That makes 2, 6. The 6's become a 0. Notice that happened here too, which is why synthetic division is kind of like the same process, just quicker. 3 times nothing is nothing. And if we finish up, we have a remainder of 0. So we wind up getting the same exact answer, which should happen because they're just the different processes for the same exact operation. Number 8. Number 8 is really just me seeing, do you really know how to do all this multiplication stuff? right? So are you struggling with the multiplication? And can you do it when it's slightly more challenging? Slightly more challenging. Okay. So what we have to do here is set up our boxes. I think that's going to be easiest, especially with fractions. So I have 1/2 x squared, negative 5x, and 2. X squared, 2/3 x, and negative 3. So 1/2 x squared times x squared is going to be 1/2 x to the 4th. 1/2 x squared times 2/3 x, so that's just going to become 2/6 x to the 3rd. Well, 2/6 is really just 1/3 x to the 3rd. And 1/2 x squared times negative 3 is going to wind up being negative 3/2 x squared. Negative 5x cubed. That's going to become negative 10/3 x squared and 15x. 2x squared, 4/3 x, and negative 6. Now we got to worry about combining all these like terms together. Well, this first one, 1/3 x cubed and negative 5x cubed, I could create a common denominator. I could type it in my calculator, however you want to wind up doing it. But you're going to wind up getting negative 14/3 x cubed. Same thing's going to happen for these three like terms. But if you do that, however you wind up doing, you're going to get negative 17/6 x squared. And the last one here, we're going to get 49/3 x. Some funky fractions, but nothing we can't handle, especially because we're allowed to use that calculator. So I have 1/2 x to the 4th is the first term, minus 14/3 x cubed, minus 17/6 x squared, plus 49/3 x minus 6. This is a totally perfect, acceptable answer. What you could do, if you really wanted to, you could multiply through or divide out to make it so that the fractions kind of go away and we just have one fraction out front. But it is kind of unnecessary, so we don't need to worry about that. Let's take a look at the next one. Same set of axes, graph this function. So if I want to graph this function, I have x and x. I need to know some roots. Roots are just a fancy way of saying the zeros or the x-intercepts, right? Where is this graph crossing the x-axis? So if I type this in my calculator and y equals and hit graph or hit y equals second graph, you'll see a table of values. So you'd start to see some of the factors showing up, right? Some of the factors showing up. So you're going to wind up getting a couple of factors. One of them is going to be an x value of 1 and an f value of 0. So you're going to have a solution here. The other one you're going to get is negative 6 and 0. So those are going to be good key points for us to use. And then you're going to see that there are other points that are usable, right? For example, if you put in 0, you get negative 6. And if you put in negative 5, you also get negative 6. So these points you're going to wind up using. And then you're going to have a graph that looks something like this. Unfortunately, I didn't give you a big enough piece of graph paper, so it doesn't fit. Label it F, and you are all good. It then says state the zeros, so the roots. So the roots are going to be 1 and negative 6. These are the roots, and you're done. Hopefully this video helped. Make sure that you understand that these, this last question, it's a throwback question from Algebra 1, so if you don't remember it, we're going to do it. And, some of this multiplication stuff really isn't that bad. Just use your calculator. All right, best of luck. Hopefully you had a nice week.